Hi everybody, good afternoon. There is a new room released by TryHackMe, Linux Threat Detection 1. Explore how attacker break into Linux system and how you can detect this in logs. Basically, this room, I think it TryHackMe is building something about SOC or something that might build in models and then maybe more advanced stuff later on. So early Linux, because I said with the rise of cloud computing, the Internet of Things Linux system are getting even more popular than before. You can find Linux almost everywhere. There's a nice room to do Linux login for SOC. If you didn't do this one, learning objective, understand the role of risk of SSH in Linux environment. Most of this room later on is about SSH. Learn how internet exposed service can lead to breaches. It tries process tree. Process tree is important. Mostly anything in Splunk, anything to solve the rooms. Some prerequisite if you want to do the other room. They give us this and it's better do your SSH to Ubuntu. Where is? Let me use this SSH Ubuntu at IP. What's the password? Okay, we are now this machine. We are okay. We're logged in. Now we did that. Initial access via SSH. Popularity of SSH. Of course, SSH is like the management how to manage Linux servers. One most popular initial access method. Linux server is exposed. SSH, a common remote access service used by teams worldwide. Nearly every internet-facing Linux machine has SSH enabled, with shutdown reporting over 40 million machines. Okay, let's see it. In 2025, only some administrator enforce secure key basic authentication. Usually, that is the method recommended to SSH to machine, not using password. So this is hey, this is showdown total result 35 million here. This is how to create a SSH key in Linux, easy step by step. Yes, yeah, it is a lot of website or ask ChatGPT or anyone if you want to use because your login password is not recommended in any case. Linux you use the keys for login. Initial access via SSH, much like with RDP usually for Windows, SSH is both powerful and also SSH in Windows often poorly defended. In fact, both protocols are tracked and the external remote service in Mitri technique. That Mitri technique when we do rooms, external remote services. This room is free. You can find all the links in the room. Common risk when using key-based authentication. Threat actor access a service or source code where private SSH key have been stored, like a GitHub repository or Ansible automation. Oh, this yeah, Ansible remind me. Threat actor steal SSH key to server by infecting these too many rooms when related to keys. Additional risk when using password-based authentication. Right, you can set weak passwords, and this is don't ignore it. Sometimes people with testing they just use 1, 2, 3, and then they forgot them or give it to net, like for example, network engineer accidentally expose and do and secure SS server to the internet. Things like that can happen. That's why audit is important. Most real-world Linux attacks, such as those by Outlaw Group, what's this one? Start from one of the scenario below. However, you should also be aware of more advanced risk like vulnerability in SSH server itself. Like there's a room here that Erlang and session hijacking. These two rooms. This one, what Outlook Group use SSH boot force to deploy crypto jacking malware in Linux servers. This is the room. You can check this room for this CVE. And then what remote service session hijacking, SSH hijacking. It's too many pages good to learn. So now they give us this first of all. This room is more direct question you solve yourself. When did the Ubuntu user log in via SSH the first time? The first time, of course, when we're doing logs, so we need to go to Let me put in the middle of the screen. You need to var log, var log folder. You get that. Let's switch to root some logs. We need authorization. Let's check the easy. Sorry, the tmp file. There's some strange in this file for this room. I get a bit confused of it because it is Ubuntu. What the question is? Still logged in. That's me. Uh, is August 26, 25. This log is not full for some reason. I don't know why. There's some the way that system is configured. It a bit confusing. But where's the other file for the fail one? Where is it? WTMP, and then there is, where are you? The BTMP. That's so. Let's solve the room the way that room is. A bit confusing this log. Why isn't recorded answer the 20 when there is it 2024? That's the date. Me September. Then there is August, and I tell you begin in October 22, 2024. Now the next one is of course the usual suspect, the auth log. So you can see the auth log as much. Why there's no colors here? Um, so for this you can do what are we looking again? Login. Usually the login, if you go, it is always that accepted. I think I need to switch. This terminal doesn't give me colors. Uh, let's go out. Let's do grep accepted, because we can do accepted from the auth. Some colors, so we can see things that are accepted. But for example, we need to filter in Ubuntu, and we're talking about SSH. We can play with get regular expression minus a. Um, we have the SSHD. We can do anything after accept, and then the next line, it will be Ubuntu. Anything the word Ubuntu, and then we can see SSH accept public key for Ubuntu. We can go to head -1, but when we get confused in this log, it tell you October 22nd, but doesn't show you the year. Normally Linux, when you show like that, it shows this year 2025. Now we get confused. I get these. I think these two system of login in this machine. So you can see 20 to 22, and then he switched to 24, the 24 format. I think this one is some kind of a different recording system. These two of them, some one is recording like that, and the other one is recording with dates. So basically, you can see this one start recording in the year. So the assumption is that's the one that he's looking for, and you can see. Because if we go with the color, so you can see it start with, it is using public keys in 24. He said accepted public key for Ubuntu, so he's not using password. So you can say, did the Ubuntu user use SSH key instead? Yes, he's used SSH key in this one. So we can see that. Now let's go now detecting SSH breaches. For example, SSH breach example. Now imagine a common real-world scenario. An IT administrator enable public SSH access to the server, allow password-based authentication. This is the dangerous one, and sets a weak password for one of the support user. Combine these three actions inevitably lead to an SSH breach. You can see, for example, from this example screenshot, you can see fake password, remember when you log in and like a salt and blue team, remember each log what, so you can grab the file, so you can know the word failed, it's part of the or accepted the keyword, so you can know them, so you can see fail, 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 and then pop, you can see multiple failed login followed by success, login from an external and trusted IP address, login by password and insecure authentication method. uh, 3 indicate a confirming theme support breach. So now you can make a conclusion there. Detecting SSH attack on Linux, you don't need to learn dozen of field like Windows. Say the hate Windows login. Type 1, type 2, type 3, type 4. The grep straightforward will give you, for example, here he's using grep locate grep minus e accepted. You don't need the e because you're only searching for one word. You don't need to have fancy grep for this. I usually don't like the cut because you don't need to cut and then pipe it. You can grab straight the file to best of my knowledge. Login of Ansible. In this case, it's just scenario. For example, the first login appear legitimate to use public key authentication. For example, accept public key, and then suddenly it switched to password because it's targeting the user, the J Smith. Login for J Smith. The two login of J Smith are more interesting is as there are three red flags: password-based authentication, login from external IP because you look for the IP, and the time difference between the login. One of the login must be at night for the user, right? Still, to make a fine of it, you might need to investigate more details. Username: who owned the user? Is it expected for them to log in at this time? Because you can't jump the guns, you need to follow, because maybe that user work night shift. Source IP: what do, for example, these tools, because you can put them in your bookmark, and this one for, okay, that's, oh, this is a new IP and domain threat enter. That is a nice room if you didn't do it. And this one, sockwork, book and lookups. These are nice two rooms if you want to go through them. Next step is the login space. Should I analyze user action following the login? Okay. They tell us use authentication login and check for brute force attack. Now, when did SSH? We've been in that file. Let's continue on it. Where is our shell? So in this case, if we don't know if it's Ubuntu, we just mean uh, we're looking for SSH. Uh, we can continue the same fancy way we're doing now. Where is that star? Failed. In this case, we're looking for failed to see what's going. Well, failed password for root. Why it looks smaller? What head 10. Remove the head. We want all the fails. So if you do the fails now, when they start, you can see failed to release session. That's not interesting. We're looking for failed password. For failed password, so we can make it more because we know failed password, so we can know the text is password for, so what password, I forgot password. We can just to get the whole thing's clearer, so you can see a failed password. And if you look the start with it, because we can know from the to know because same IP, so it's the same IP. It's like brute force here. Um, no, near it switch an IP. I don't know what this for. Is it part of the brute or not? But you can see. Oh no, there's a switch in IP too. Yeah, that's part of the brute. You can see continue IP address with a fail. So when it start again from 197.39, you can assume it start there. Let's see if it accept it. I don't know why I didn't use the time in this room because it's like you got worried people get confused between this one and this one because the IP is this one at 197 sweet because if you say the time it's more about this so this one it failed separately the time is 34 but this one is closer you can see they're close to each other this one are far so I don't think this one is part of the brute forcing. I'm not sure. The 19346, these two IPs are just suspicious, but this one I think where it start. Then it tell you answer the format which user did the botnet attempt to breach. Uh, so we can know is a root. Then we have invalid user sol. So they try sol. They try root. Invalid what? Another invalid. We have root. And then we have Roy, so we have Roy, Sol, and invalid Roy. Who is the fourth one? Invalid user. So we have user, we have root, and we have Roy, and we have Sol. So with RS root alphabetic order. So uh, user root, Sol. Uh, Roy RS. So Roy is first, Sol, and then user. Now, finding which IP managed to breach the root. To breach the root, so we need to change our. So it's not failed. We don't search. We can just look for accept. Uh, accepted. We don't. Which IP managed to breach the root user? So we can accepted. We can get the same syntax of root. Let's see what it gives us. Accept the password for root from 191 port 5. Uh, we can go to this 91. Uh, we can confirm it's that one, but let's not do it, just do accept it. Just do anything that was related to root. Let's see what's happening. I want to see the end of failed. Where's that? Faithful password, disconnect, fade. Where is the accept that we just saw now? Disconnect, fail. Like I don't see it. Fade password for root. Fade. Where's the accept? That's it. You can see the same IP, this one and this one. So it's failed for root. Then now here he found the password. He was able to crack it. So you can see the same IP address 91.91.224.2. So this is the IP that was able to was part of bootnet. So you need to find the one that part of the bootnet, not like a normal user. No initial access via services. Linux and public service. Linux system often hosts public facing like web, email, and all of that. So they also compromise the core of most firewall and VPN. Linux these days is everywhere. That's why you have this, for example, CVE, Zebra Collaboration, Exposed.api, CVE in Palo Alto Firewall, WordPress. WordPress is which one? Researcher warn of ongoing attack exploiting critical Zimba. This is I remember it's an old one, if I remember correctly. What is this? Docker. Threat be operation midnight eclipse post exploitation activity. This one unit 24. It has a lot of nice article. This website part of Google. It's nice to read this one. Rapid 7 you press here. This admission upload. It's well known this thing. This is 2005 15. Uh, brute force also exploit and secure WordPress website from WordPress, upload a backdoor to Linux host. There's too many rooms they always use in WordPress for this. Using application log. So if you want to know whether your email server was breaches, you naturally reach for an email logs. On the other hand, can you expect an application to log I'm being exploited with a 0 day right now? Of course not. That's the native application log. They rarely tell the full story, but they can still provide unique artifacts for analysis. For example, you can use weblog to detect a variety of web attacks, use database log to detect suspicious SQL queries, VPN log to detect abnormal VPN, and so forth. Web as initial access. Any publicly exposed application can lead to a Linux breach, especially vulnerable web server. For example, here we're talking about an app that, for example, just do ping. For there's a lot of rooms in CTF do this trick of the ping, and then suddenly when you go to the log, you see ping IP normal, and then suddenly host, and then suddenly you find someone putting just a word, and then you send who am I, and then there's a room called command injection for this. You can see there is a command injection here. Weblog analysis, the request coming from, for example, we can see 1014 seem odd. Instead of an IP, the client put Linux command. So you can see this is command injection. It's one known trick. They take us to log nginx access log, and let's investigate. Let's go to that log. Um, Vim. You said nginx access log. So it's like so. If we look for this log, you can see it's not too big log. This one. You can see it's starting a get request for the ping function, the ping app host. So you can see it's IP, that's normal. You have 200 requests, so it's not done. Then ping host, that's normal. And then hello, now it start flipping. It starts sending, and you can see 500 the request of the server. And then pin host, who am I? Also 500, because it's, and then when you put when you do command injection, suddenly it's 200 requests, so you got a reply. And then if you go down, you can see cut opt is that's what he did. So he has a ping is cutting this file, so you can check this file what is it. That's the web application. And then you can see the last one. If you do it in chef, you can see it's you can see socket stream, and you can see python. You can see it, this is a python socket, just URL in code. So this is uh, a python socket. So if I go now, we can see the file. We can go to that file that it was the application used, and we can see this is the file. That's the ping function. Apt-get ping response clear because up fast API command fping went so there's a little CTF here. So the file, of course, we got it is this one, and then when you read it, you can see the flag. Where is it, the flag now? I like this room. It's the way that you sorry, you investigating things. Now detecting service breach. Building process team, as I said, is key for a blue team in Splunk or anything to detect who the parent is. So you always, when you see a process, for example this one, you start from the bottom up. For example, you start here from a mysterious HMI, you see HMI, you get for example the PID, then you look for the parent, and then the parent search for it. You search for the process with the PID of 3905. For example, the result didn't help move in. So if sometimes you do something here, it doesn't it give you a clear picture because here it's a binary sh-cumi. So then you find the parent, look for it again, and when you look, you can see the app is running. Then you search for a process with a PID, and that's why this Linux server has an auto search, or the audit is active, so it's easy to search for things. For example, now let's practice with this example. O search minus I minus X, O search minus X. For example, who am I? Because we already have the application, so you can see the command there, and then we can see the PID and parent. So for us now, we need to look for the process. The command to look for the process is just minus I dash dash. So you can minus I. Uh, Now we go to the PI. Sorry, where are you? PID, and then we know the parent is this one. So you need to look who's the parent of this thing, and then we see it's binary as ping, so we know the command, but we want more, so we can go more up the ladder, so we can see what. So we came here to this one. Now we're looking for the parent of it, so now we need to go to who's 577, and then if we go 5, oh no, we find it's a Python, the apt try ping me main.py, the one that we've been inside. So we know now, let's see, so we did the same things here. This is more fancy, and then of course if let's first do the answer, then we jump. What's the PID of the speech, the parent process, or the PID of that who am I? We got it because when we search for the who am I, we got the parent is this, the parent is 108. Let's do that there. And then moving up the tree, the app, remember when we went down, we've been fine. That's the top suspect, the try ping me app. So we got that, and then we can do the same trick. This one it mean, if this is the parent, it mean what else this one is hiding. So basically we can do the same. We're not if you, because this one is because is the main one, so it will be the parent for what. So we're looking for any process that the parent is 7 7. If you do this, would be too much information, because now we're looking for only because remember we're looking for this title. This is give us the command, so we're looking for grab. You can just grab the command, and then we can see here, so we can this is the command we saw before. So all of this was triggered by this main process. This is the parent of all of them. And then what's the question? He said, which program did the attacker use to open the reverse? So we can see the first one is just who am I, ls pw, and then he cut the code, and when he checked the code, basically around this. So what is this? It's Python. So we can see it's a Python shell. I like this one, these tools, because the audit is enabled in this box. This is not by default Linux. I think you need to activate it. The way that you search and things like, maybe maybe there will be a room some in Linux like that to play with it. Yeah, guys. So this is nice. The process tree is very important investigation always. I think we're almost done. Then advanced initial access, a human-led attack. In the previous task, you explore initial access via SSH and expose services. But what about phishing and USB attacks, so commonly seen in Windows environment? Since Linux primarily is a server OS operated by technical people, it is harder to trick a system owner to just plug something. But there is a lot of history. For example, now you can see an example: an IT member looks for a solution to a server issue and go to GitHub or something, and then or a Stack Overflow and just copy. For example, this is dangerous because You curl from a link if you don't know, and you tell bash, and if you are root, just it will. And this is like an IT member didn't check the script content, and is appeared to be made with silent infected the server. This is like true stories. And here the pipe. If you remember the news last week about 2 weeks or you the Python. What's that? The whole big story of of Python. What that RPM. This is how. Yeah, this is an article for that. And then we have the mistype package. Yeah, that's where they do the attacker because they create libraries like fast API, and you type in fast and you just install dangerous one. And see here is a real case you can check. Malicious PI, it's always in Python because a lot of them package store cloud token over 400,000 down before move because people do mistakes. You type and it just when you try to install something, make sure you know what you type in. Supply chain compromise, while not so unique to Linux, you should also be aware of supply chain compromise. This attack breaches software first and then infect all its users with a malicious update. For example, they tell us the backdoor in XYZ, this is SSH was very dangerous one. If you remember, the breach of the TG action resulted in the leak of thousands of licensed keys and access token. Oh, this is CISA. Supply chain compromise of third-party TG action charge fee CVE 2025-30066. Detecting the attack. Oh, all initial access technique described in the room can be uncovered through process tree analysis. You start with a triage triggers such as SIM alert and suspicious command or connection to known the tree. So you start. Why would the web app run Who am I? Can it be a web application breach? You check from the bottom. Who am I? The Spawn Shell, PHP web application, Apache web server, enter the top. Why would the TryHackMe app run these commands? Can it be a supply chain compromise, for example? Tar command, base64 command, things like that. This is more introduction room, so you're not going deep in these things. Why would Tom log in via SSH and download a cryptomania miner? Can it be SSH bridge? Now, which initial access technique is like used to trusted app? Yeah, when it is trusted app, usually is most of the problem. I think is supply chain compromise when trusted app. Which detection method can be used to detect void of initial access technique? This a process tree analysis. Yeah, this ask echo, it's always popping up. As a conclusion, great job with some initial access technique and an especially complex topic. The process tree analyze. While it may seem hard to apply, you will happily use it on a daily basis with some practice and more convenient SIM interface using the system log source and audit D. That's the audit D we've been using now. You learn to identify how attacks start and are now ready to learn how they continue. Key takeaway: attacks on SSH are widespread, but they are easy to detect via authentication logs. Exposed services are always a risk since they can lead to full Linux compromise. Check out the bulletproof penguin room. Really? Which room is this one? To learn how to harden and secure Linux server. While phishing is not common in Linux, human-led and supply attack are still possible. Process tree analyze is your best approach, and we did that. What Penguin is talking about? I do remember this room. Bulletproof Penguin. Is it free room? This one. Let's see. Only subscriber. I don't remember this room. Oh, I remember this one. Let me leave it like that. If I didn't do video for it, I will do video for it. Thank you very much, guys. yeah, if you have question, let me know in the comment. Please like and subscribe, and thank you very much and have a good day.